So this is the redox reaction lecture 3. In this class, we will discuss about the oxidation number, how to calculate the oxidation number. Uh, so uh, I will continue this class from the previous class that I taught about the oxidizing agent and the reducing agent, and with one problem where I will show you how we will decide that what is the oxidizing agent and what is the reducing agent, and who is oxidized to another species, like that. So there is example. So this is a redox reaction. Uh, so this is a redox reaction. So in this redox reactions, I have to say that which is the oxidizing agent and which is the reducing agent. So uh, to write the answer, before that to write the answer, I will show you the oxidation state of this copper and whatever is there. So here, if you see, this is the Cu2O. So the copper has +1 oxidation state and oxygen has -2 oxidation state. Similarly here, the sulfur gives a -2 charge. So copper will have +1 oxidation state and sulfur will have -2 oxidation state. And copper, this is the metal, so copper metal is the free here, so oxidation state is 0. And for that SO2, the sulfur will have the +4 oxidation state and oxygen will have -2 oxidation state. So if you see clearly, this is a redox reaction. Why I am saying that this is a redox reaction? Because this copper +1 is goes to 0 oxidation state. It goes to the 0 oxidation state. So copper +1 goes to the copper 0. So basically here it is reduced. It is reduced to 0. So when it will be reduced to 0, to gain 1 electron. So this is a redox reaction. So this is a reduction reaction. This is a reduction reaction. But what about the oxidation reaction? What about the oxidation reaction? If you see the sulfur, so sulfur has the -2 oxidation state, but here the sulfur has the +4 oxidation state. So sulfur -2 is goes to sulfur +4. So it is oxidized. So it is oxidized. So it is a oxidation reaction. It is a oxidation reaction. It is a oxidation reaction. So here the copper goes to +1 to 0. So it itself reduced. That means it is a oxidizing agent. Is a oxidizing agent. So oxidizing agent means it will oxidize to another species and it itself they reduced. That's why it is oxidizing agent. So similarly here the sulfur will be the reducing agent. So reducing agents means it will reduce to another species, but it itself oxidized. So it itself oxidized here. Here it itself reduced. That's why it is. So this is the reaction of the reduction reaction. This is the reaction of the oxidation reaction. So reduction reaction means oxidizing agent. Oxidation reactions means reducing agent. So these are the tricks to remember about the oxidizing agent and the reducing agent, and which is the oxidized and which is the reduced in a redox reaction. So this is a redox reactions where we can easily say that this is the reduction reaction and this is the oxidation reaction, and here which one is oxidized and which one is the reduced. So this is a one example. Whatever I taught in previous class, based on that theory, based on that knowledge, uh, here I have shown this problem and the solve also. So in this way, you guys have to solve this problem and you guys have to see the oxidation number. So here up to that we have realized that in the redox reaction chapter, basically there are the two reaction. One is the oxidation reaction, another is the reduction reaction that I have taught in the first class. Then I taught oxidizing agent, reducing agent. So basically most of the cases you guys have to decide which is the oxidizing agent, which is the reducing agent based on the charge, based on the oxidation number of the metal, or based on the electron transfer theory. In the first class I taught about the classical theory. In this way you guys uh, can say it is oxidation reaction, it is a reduction reaction. But in the second class I taught about the electron transfer theory by which we can say it is oxidation and reduction. But if you see, the oxidation number is a very important topic, or how to calculate the oxidation number and what will be the oxidation number of the every element in a complex, in a species which is going to participate in your redox reaction. So this is a very important, because if you do not know the oxidation number of any element, you cannot say which is the oxidizing agent, which is the reducing agent, and what is the what reaction is going on. So now we will know about little bit and in more details about the oxidation number, about the oxidation number. So we know about oxidation number, how we will calculate, how we will know oxidation number of the element. So suppose there we have seen that already, we have seen that there are some pieces like Na2SO2O3, Cr2O7 2 minus. We have seen hydrogen, oxygen, like Fe2O3. So in this case, what will be oxidation number of this metal, and for this hydrogen element what will be the oxidation number? So to know the oxidation number, there are the some basic rule we have to know first of all. So first of all, there is a rule. The rule number 1 is there. They have they have said that for the free and the uncombined atom, which atoms or the element, if I say the atom and the element is the M, suppose M, which is not attached to the another, which is not attached to the another M, it is the free, it is the free. So then the oxidation number of this atom or of the element will be the 0. So like O2, Cl2, O3. Suppose I have said that this is the Fe, iron metal. So iron metal is a free, it is not combined with this another element, so oxidation state will be the 0. But suppose oxygen Cl2O3. So what will be the oxidation number? Oxygen means O double bond O. Here one oxygen atom is connected to the another oxygen atom, so both atoms are the similar. So here the oxidation number will be the 0, like the Cl2. So here the oxidation number will be the 0, like the ozone, oxidation number will be the 0. So basically they have said that in an elements in the free or the uncombined state, each atoms bear an oxidation number of the 0, like the sodium. it is already free, like the magnesium, like the aluminium. These elements are the free, they are not attached with this another element. So that's why it has the oxidation number 0. So this is the first criteria to know about the oxidation number. The second criteria will be there. Suppose there are the ions. For the ions, the composed of the only one atom, then the oxidation number is equal to the charge of the ion. So this comment, so to understand this comment, we have to know the general mechanism to decide to divide the cations and anions of a metal salt. Like I already said in previous class that like that mx y. So this is a metal salt. We can write this metal salt in cations and the anions form like that m x m y plus y n x minus. So here we can say that suppose this is a metal. Okay, so this is a metal. So this metal is connected to y number of anion. Y number of anion. So suppose y number of anion. So what will be the oxidation state of this metal? The oxidation state of the metal will be the number of the anion. This is the number of the anion. Like that MgCl2. Here magnesium is attached to chlorine. So what will be the oxidation state of the magnesium? Magnesium plus 2. Okay, like FeCl3, like the FeCl3. So this Fe, this iron is connected to the 3 chlorine. So oxidation state of the iron will be the plus 3. So this is the basic rule to know what will be the oxidation state of a cations and the anions in a metal salt. Okay, so we can say that for that alkali metal, basically for the alkali metal, like we can say the sodium, potassium, it will have plus 1 oxidation state, and alkaline earth metal, or the alkaline earth metal like the magnesium, it will have the magnesium plus 2 oxidation state. Okay, so there is the basic concept that we can say of a metal salt what will be the oxidation state of the metal. So the what will be the oxidation state? The number of the attached anion. So this is the basic idea. Suppose the aluminium, Al, we know that AlCl3. So aluminium will have aluminium plus 3 oxidation state. So in this way, because the aluminium is attached to the 3 chlorine, so here the number of the chlorine atom is 3. So that's why the oxidation number of aluminium is plus 3. So this is the basic rule of the two. So there is the another basic rule is that we know that oxygen, we know the oxygen basically general oxidation state is -2. Oxygen will have the -2 oxidation state, but depends on the structure, depends on the compound, it will the oxidation state of the oxygen will be the different. How? Suppose O2 oxidation state we know that 0. Suppose O3 oxidation state will be the 0. How? Because for the ozone gas, this is the ozone gas O3, oxygen O. So that will be the +1 and that will be the -1. So -1 plus 1 plus 0 equal to 0. So 0. So ozone will have the 0 oxidation state, oxygen will have the 0 oxidation state. So we know generally oxygen has the oxidation number -2, but in case of peroxide, in case of superoxide, what will be the oxidation state of oxygen? Suppose the peroxide. First, I will discuss about the peroxide, like the hydrogen peroxide, H2O2. So what will be the structure? We know that the structure is like that. Okay. So what will be the oxidation state of the oxygen here? Because we know that hydrogen has the +1 oxidation state. This hydrogen has the +1 oxidation state. Suppose this is the X, this is the X. So 2x plus 2 equal to 0. So it will have X equal to -1. So here for the peroxide case, oxygen giving -1 oxidation state. Like that NO2O2. We know that sodium give +1 because it is alkali metal. So it will have 1 into 2 plus 2 into X equal to 0. So here also it will have -1 oxidation state. So for the peroxide case, oxygen will have -1 oxidation state. But what about the superoxide? Suppose for the superoxide case, suppose the potassium K2, rubidium, RbO2. So here, what will be the oxidation state? We know that potassium is alkali metal, so it will have the +1. So +1 plus 2x equal to 0. So x equal to -half. So you see, we know that oxygen has the general oxidation state -2, but here depends on the structure, depends on the attached element, which type of the element is attached to oxygen. Okay, based on that, the oxidation number of oxygen will be decided. Here the potassium KO2, so that's why it has oxygen has the -half oxidation state. Okay, similarly if you see the rubidium, for that rubidium case also rubidium +1, so it will give also -half oxidation state. Faction in faction for the superoxide is giving the -half, for the peroxide case it is giving the -1. Okay, so basically oxidation state of element depends on which type of the element is attached. Like that, if I discuss about another element, suppose the OF2, we know that here the fluorine is more electronegative than oxygen, but the fluorine has -1 oxidation state. So what will be that? X plus 2 minus 1 equal to 0. So x will be, so in this case the x will be the +2. Now we know that oxygen has the -2, but here x is giving the +2 because it is attached to fluorine. For that O2F2, suppose for that O2F2, what will be the case? It will give the +1 oxidation state. So from that theory, from that rule, we have to know the structure, and also we have to know which type of the element and which type of the metal are attached to the oxygen. Based on that, it will give the oxidation number. So there will have another rule, the fourth rule. What will be the fourth rule? Fourth rule is that basically we know that proton, hydrogen gives the +1. Okay, hydrogen give the +1 charge. But when this hydrogen attached to metal, then it acts as hydride. It acts as a hydride. hydride means H minus. That means when it attaches to the metal, that means this hydrogen gives -1 oxidation state. So how? Like sodium hydride. We know that sodium has the +1. So +1 plus X equal to 0. So X equal to -1. Like the potassium hydride, it has also, like the lithium hydride, it has also hydrogen gives the -1 oxidation state. There is a fifth rule that fluorine, we know that fluorine is more electronegative element, so fluorine will have -1 oxidation state. But there are the some example, there is the some rule is that like chlorine, bromine, iodine, these are also belongs to this fluorine group, but fluorine is the more electronegative than the chlorine, bromine and iodine. So when this chlorine, bromine and iodines combined with the oxygen, for that case we will say oxygen act as a anion. What I have said that here, when oxygen adds the fluorine, then this fluorine act as a anion, then it act as a anion. But when the oxygen attaches to chlorine, bromine, iodine, then oxygen act as anion. So when oxygen act as anion, that means this type of the halogen element act as cation. So here depends on, actually we can say depends on electronegativity. Okay. So there is another rule. So this is the basic rule. This 6 number rule is the basic rule. Basic rules means that when we will go to calculate the oxidation number, any element or the species, then whatever charge you will have, you sum the charge and sum of the charge will be equal to the 0. Sum of the charge will be equal to the 0. So the algebraic sum of oxidation number, the oxidation number will be equal to 0 or will be equal to charge. So 0 means when it will be equal to 0, 0 will be for neutral element, neutral species, and the charge for any ionic species. It will be the cationic, it will be the anionic. Let's start one example. Like that. Let's start one example. CO3 2 minus. So this is a anionic species which has charge is -2. But now I have to calculate the oxidation state of the carbon. So what will be the oxidation state of the carbon? So first I have to write down the oxidation state. Let us consider the oxidation number of the carbon is X. So we know that every oxygen atoms gives -2. So here suppose so 3 minus 2 equal to -2. So here the sum of the oxidation number is equal to -2. Okay. So X equal to, what will be that? X plus minus X minus 6 equal to -2. So X equal to +4. So X equal to +4. So carbon has +4 oxidation state. So this is for the anionic species. The sum of the oxidation number is equal to the charge. But for the neutral species, suppose if I say the magnesium chloride again, So magnesium, we do not know what will be the oxidation state of the magnesium. So let us consider the X. We know that chlorine gives the -1. So 2 into 1 equal to 0. So X equal to minus. So X equal to +2. So here, so this is the neutral. So this is the neutral, but this is the anionic. So that's why the sum of the oxidation number is equal to the charge. But here the sum of the oxidation number is equal to the 0 for the neutral case. Okay. So in this way, and we have to remember these 6 point, these 6 tricks or the 6 points when we will go to calculate the oxidation number. Okay, when we will go to the calculate the oxidation number, we have to remember this type of the example and these 6 points. And there is the general rule. One is the general rule is that for metallic species, for the metallic element, will have the positive oxidation state, and for which are the non-metallic, okay, it will give the minus charge. Okay, so negative oxidation number, and for the metallic element will have the positive oxidation number, and for the non-metallic element will have the negative or the positive. It will actually it will have the negative or the positive, because that depends on the structure. I will show you some example. Depends on the structure, and also depends on which type of elements are attached. So for the metallic case, it is the fixed. For the metallic case, it is the fixed that for the metallic element will have the positive charge, but for the non-metallic, it will be fluctuate. Somewhere it will give the minus charge, somewhere it will give the positive charge. That depends on the structure, and then depends on which type of the element are attached. So based on this type of example and this type of concept, based on this type of concept, I will show you some example where easily we can say what will be the oxidation number and what will be the charges there. Okay, like P4O10, phosphorus, oxygen, both are the non-metallic. So we cannot say what will be the oxidation number, that for oxygen it will be the positive or the negative. So these are the non-metallic. So oxygen, generally we know that for the oxygen, sorry guys, just let me yeah. So for oxygen, it gives the -2. So what will be the oxidation state for the phosphorus? Let us consider phosphorus has X oxidation state. So there is 4 phosphorus. So 4 into X plus 10 into -2, it will equal to 0, because it is a neutral species. So this is the 4x. So -20 will be 0. So X will be +5. So here every phosphorus atom has +5 oxidation state. Okay. Now there is another example, hydrogen, gold, Cl4. So here what will be the oxidation state of the gold? So we know that this is the metal, so it will have the positive oxidation state, but we have to calculate the what will be the positive oxidation state. So we know that this hydrogen gives actually +1 here, so it is giving the +1. We do not know what will be for the gold, and we know that chlorine. Look here, this is the very interesting thing. Here the hydrogen is attached to the metal, chlorine also attached to the metal. But between this hydrogen and chlorine is the more electronegative. So chlorine will be negative. So 4 equal to minus 1 equal to 0. So x equal to x minus 3 equal to 0. So x equal to plus 3. So silver will have, gold will have plus 3 oxidation state. In this way, if you see, if we calculate MnO, it is very easy because oxygen we know that minus 2. So X will be plus 2. So manganese will have the plus 2 oxidation state. So this is the basic idea. This is the basic example to know the oxidation number, and there are the 6 points very important. These 6 points are very important. Please remember these 6 points and read the NCERT books for the 6 points. These are the very important point. Based on that, we have to calculate the oxidation number. And if you calculate the oxidation number more example, so it will be very easy for you to know how it is actually solving. Okay, so here I will discuss about the some MCQ question, the oxidation number, basically on the oxidation number. Okay, so now there are oxidation number. It is possible that oxidation number is plus half. Obviously possible. Already we have seen that there is example. This is the example of the super peroxide. Suppose this is the O2 and F2. Because fluorine is more electronegative than the oxygen. So what will be the oxidation state of the oxygen? So it will have the 2x, it will the minus 2 equal to 0. So x equal to plus half. Sorry, in this case, sorry. In this case, it will have the plus 1 oxidation state. But for the OF2, for that case, it will have. Sorry, just see me. Sorry. Yeah, it will have the plus half oxidation state. That is example. We can say that like so it will have the plus half. Sorry, it will have the plus half oxidation state, and for that case, it will have the plus 2 oxidation state. But plus half oxidation number is also possible if we say there is example. Okay, just okay. I will tell you the next class the example, because now I cannot remember, but it is possible. But it is possible. Second question is the oxidation number of oxygen in the ozone. It will be the 0, because we know that oxygen is oxygen like that. So it will the plus 1, this minus 1, it will the 0. So basically minus 1 plus 0 will be the 0. So it is the false. So that will be the correct answer, false. So helium element has an oxidation state, it will be the 0, because helium, it is free, it is not attached to the another element. So that's why it will have 0 oxidation state. So this is the first point. So from that concept we can say helium is free here, it is not combined with this another element, so it will have 0 oxidation state. But what will be the fourth question? For what will be the fourth question? For that sodium hydrate, what will be the oxidation number of hydrogen? We know that hydrogen gives the plus 1 oxidation state, but here the hydrogen attached to the sodium, so it will have the minus 1 oxidation state. So it will be the correct answer. Now, it's a very important question. What is the oxidation state of the chromium CrO5? Okay, So this is the very important question. Uh, Generally, we will write that like that. So oxygen gives the -2. So it will be x. So plus 5 minus 2 equal to 0. So x equal to plus 10. But there is no option plus 10. So it is the correct procedure. Now why I am saying it is not a correct? Uh, so why I am saying that it is not a correct? Because I have taught in the past that already I have said that oxidation number, when we will go to the calculate the oxidation number, that depends on the which type of the element is attached and what is the geometry. Okay, so what will be the geometry for the chromium pentaoxygen? So CrO5. So what will be the geometry? First we have to know. So it has the geometry like that: oxygen, oxygen minus, oxygen minus, oxygen minus, oxygen minus. So here 4 oxygen is giving -1. So total -4, and 1 oxygen, this 1 oxygen is giving -2 charge. So what is happened here? Suppose let us consider the oxidation state of chromium is the X. So X plus 4 into -1 plus -2 equal to 0, because it is a neutral basis. So what will be that? -4 minus 2 equal to 0. So x equal to plus 6. So it will be the correct answer. So here the chromium has the +6 oxidation state. So see here, nothing is depend on which type of element is attached. Depends on the geometry. Here we have calculated the oxidation state of the chromium. Okay, 6 number question. What is the oxidation state of Cr3O2 of the carbon? So this is also the same question to question number 5. So to know the oxidation number of the carbon in the Cr3O2, we have to know the geometry of Cr3O2. Okay, so let us draw the geometry of the possible geometry of the Cr3O2. It will be like that. Suppose I do not know what will be the geometry. So it will be like that. I have drawn the cyclic. Now I am attaching 2 oxygen. So this carbon has the 4 valency. This carbon has the 3 valency. It has the 3 valency. So it will be not the geometry. We have to draw in this way the geometry of the Cr3O2, that carbon will have the 4 valency and oxygen will have the +2 valency. Okay, so this is the concept. We have to draw, and we also have to see the valency of the carbon and the oxygen. Here it is not matching. So if we draw like that, suppose if we draw carbon, 2 oxygen is there, oxygen, carbon, carbon, like that. So this carbon has 4 valency, this carbon has also 4 valency, but this is the 2 valency, there is the 4 bond, oxygen is also 2 bond, it is okay. But this oxygen, this carbon is not fulfill up with the valency. So this is the problem. Uh, uh, Actually we have to know the geometry, the proper geometry of the element. So it will help to calculate the oxidation number. So what will be the geometry, the proper geometry of a Cr3O2? It will be like that: carbon, 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 oxygen, oxygen. Here we see every carbon has 4 valency, every carbon has 4 valency, oxygen has also the 2 bonded. So it is a proper and the right geometry of the Cr3O2. Now you calculate the oxidation number of the carbon. So we know that oxygen gives the -2 charge. So this is the -2, and there is the 3 oxygen, sorry, 3 carbon. So let us consider the oxidation number of carbon is X, and also -2 equal to 0. So X equal to, what will be that? I think there is, so it will be the -2 -2 -4, it will be goes there, so it will be the 4/3. I think I have mistake the option, but the answer will be, I will correct it, this question, but the answer will be 4/3. Okay, it will be the, what is the oxidation state of the carbon in the Cr3O2. Okay, I will say in the next class what will be the option, but answer will be, the answer will be 4/3. Acha, acha, acha. No, 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 no. Just see that. Okay, so now total. So I have, so this option is correct. Why I am saying that? Because I have calculated here the average oxidation state. I have calculated here the oxidation state of the average oxidation state. But here is the option, the 3 carbon is there. So what will be the oxidation state of the 3 carbon? So it is the average oxidation state of the each carbon. So what will be the um, oxidation state of the each carbon? So this carbon will have the -2. Sorry, this carbon will be the +2. This carbon will have 0, and this carbon will be the +2. So this is the average for the each carbon. So if you multiply it into 3 for that 3 carbon, so it is giving the 4. So 4 means 2 carbons will have the +2 and 1 carbon will have the 0. So that's why option D is the correct, because 0, 2, 2. Okay, so option D is the correct answer. So what will be for the 7 number question, that what is the oxidation state of the nitrogen for the NH4NO3? So to know that oxidation number of the NH4NO3, first we have to divide that species as a cation as an anion, like NH4NO3. If I write down in this way, NH4 plus NO3 minus. So just divide two pieces. Okay. So for that case, this is the NH4 plus 1. So this is the cation, this is the anion. So we know that hydrogen give the +1 charge. So let us consider the oxidation number of nitrogen is X for that. So X plus 4X will be the +1, because it is a cation. So the sum of the oxidation number will equal to +1. So X will be, sorry, that will be the 1. So X will be 4 minus 3. So X will be the -3. Okay. But for what will be for the NO3 minus? Let us consider X plus 3 minus 2 equal to -1. So X minus 6 minus 1. So X will be +5. So option 1 is the correct answer. -3 and the +5. Now, what is the average oxidation state of the sulfur? This is the question. Okay, you see, you have to very careful about that. What is the question? This is the average oxidation state, and there is a question, what is the oxidation state of the carbon? That means you have to calculate oxidation number of the each carbon. Here you have to just calculate the average oxidation state. So for that oxidation state, average oxidation state of the sulfur, we have to calculate like that. We know that sodium gives +1, because it is alkali metal. So 2 into +1, we do not know what will be oxidation state of the sulfur. Let us consider it has oxidation state X. So 6 into X, and also oxygen will give the -2. So 6 minus 2 equal to 0, because oxygen, here you see the oxygen attached to sulfur. Okay, so and oxygen we know that it is more electronegative than sulfur. So oxygen gives -2 oxidation. Okay, so it is giving +2 plus 6x minus 12 equal to 0. So 6x will be 10. So x equal to 10 by 6. That means it will be 5 by 3. So answer will be the 5 by 3. So this option C is the correct answer. Okay. Now there is another two question. What is the stock notation of the cuprous oxide? This is a very important thing. When we will see cupric, that means it is indicating that copper has +2 oxidation state. But it is saying the cuprous oxide, that means copper has +1 oxidation state. Now it is showing the oxide, that means there is attaching the oxygen, here also attaching the oxygen. Okay, so how many oxygen we have to add with the copper, then the copper will give the +1 oxidation state. If I add the 2 oxygen, that means if I write down the oxidation state CO2 copper O2, then copper will have then the copper will have what will be the oxidation state for that copper? It will have +4. It will have the +4. If we write the oxidation structure like that, okay, so then it will have 2x. So it will have like that 2x plus 2 into -2 equal to 0. So x equal to -4, 4 by 2 equal to +2. So CO2. Now if we write like that, so this is the 2x equal to -2, so x equal to +1. So this is the structure. Okay, CO2O. So the option will be the copper +1 oxidation state. Okay, copper +1 oxidation state. Okay, but there is also confusing the option copper 2 oxide, copper 1 oxide, copper oxide, copper +1 oxidation state. Because what is the stock notation? The stock notations means like that it will have the +1 oxidation state. So copper +1 bracket means it is indicating the oxidation state of the copper. Okay, when it will be the answer, so it will be the stock notation, not it will be the stock notation, it will be the chemical structure, chemical notation. Okay, when it is the showing the stock notation, that means we have to show the oxidation state of the copper. So it is a cuprous oxide. So cuprous oxide means it is indicating the +1 oxidation state of the copper. When it will be the cupric, then it will have +2 oxidation state. Okay, so CO2O will be the correct answer. Now what is the stock notation of the mercuric chloride? Again, stock notation means we have to show the oxidation number. Again, okay, so mercuric chloride, mercuric, ferric, cupric, this type of the naming showing the +2 oxidation state. So mercuric means MgCl2. Here the mercury will have the +2 oxidation state, so option will be the D, because here the mercury will have the +2 oxidation state. Okay, so in this way we have to calculate the oxidation number, and we have to know what will be the number. So this is the last class of the redox reaction. Here we have taken I have taken the 3 class for the redox reactions. In the first class I have taught about the classical idea, how we will know about the oxidation number, oxidation reaction, reduction reaction for a redox reaction. Okay, then in the second class I have taught about the electron transfer theory, by which we can say easily we can say this is the oxidation, this is the reduction reaction, and which is the oxidizing agent, which is the reducing agent, and who will reduce to another species and who will oxidize to another species. So basically the class number 2 is the most important, and class 3 also is the most important, because if you go to the higher level study for the redox reaction, higher class, then we have to we have to depend actually the electron transfer theory to know about the redox reaction, because redox reactions means the electron transfer from one species to another species. The electron is transparent. Okay, so electron, when electron is transferring, then the oxidation state, the vacant site is creating, where the positive charge creating, and where the minus charge is creating. So basically we have to know properly, you have to know properly what is the oxidation number. uh, Before reaction what is the oxidation number, after reaction what will be the oxidation number. Okay, so if you calculate the oxidation number before reaction and after reaction, easily you can say it is a oxidation reaction or it is a reduction reaction, which is the oxidizing, which is the reducing agent. uh, Everything you can say easily, but before that we have to know, we have to we have to have the clear concept about the oxidation number. So this is the important thing. uh, you guys just read the NCERT book, and also you see the lectures, and I have also given the 10 MCQ question per lecture. Whatever I have taught in per class, based on that I have given the MCQ question with solution also. You guys that do, and you have any problem you can ask me in the next class. Okay, thank you.